Alright, so this is starting with 7.5, which is simple array algorithms. So a few common things that you should know how to write, you should instantly be able to recognize, and you should don't try to make them any better. If you want to count number of matches, find a value, find a maximum or minimum, just use these algorithms that are already written for you. Okay, so to count all the values in an array of a list, check all the elements and count the matches until you reach the end of the list. So something like public int count, which will return the number in our parameter at least. This is page 302. Okay, so int matches. Okay, going to start at 0. Then we're going to do an enhanced for loop. So remember, this is going to be, well, this one's being used in a bank account in our class bank. So we have an array list of bank accounts. So we're going to go sequence through it. So we have to use the type, which is going to be coming back as account in our storage, then a colon, then the name, and it was called. The board is weird. All right. And then if the balance of my temporary one that I'm looking at is close to, matches my minimum threshold. I increment my matches parameter, go all the way through, and then I return my matches, count how many times I saw something. So this is counting, okay? Alright, finding a value. Alright, so suppose in this case for the bank we want to know whether or not there is a bank account with a particular account number. So to find a value in an array, you check all elements until you find a match. So in bank account, alright, now this one has this return type. I'm going to return an actual bank account. I'm going to return the account that has the required number so I can do things with it. I'm going to find a specific value. So in this case, since I'm going to have to go through everything and I don't really care about the index, I'm going to do an enhanced for loop. And again, going through bank accounts. Sequence through. If my current temporary one so check the account number. If it matches the account number parameter that I'm looking for, then I return that bank account to be worked with. Else, I return null. I don't give you back. I give you back no bank account. Okay, so an enhanced for loop, go through all of them, store each one temporarily in A, and then check if it's the one I need. And lastly, finding the maximum or minimum. So to compute the maximum or minimum value of an array list, initialize a candidate with the starting element, then compare the candidate with the remaining elements and update it if you find a larger or smaller value. So unlike when we're checking numbers where we want to use integer maximum and integer minimum, or max value and min value, I mean, here we're going to just assume, if I'm going through an array, that the first number is either my biggest or my largest, and then check each subsequent value in my array until I find one that's smaller or larger. Okay. So, remember the get command gets the element at the array index provided for an array list. Doesn't delete it, it just gives it back to me. can't use an enhanced for loop because I got to do a couple other things. So standard for loop. And it's an array list, so I have to use the size method and increment through. Alright, so kind of like an enhanced for loop. Now you wonder, up to here I could use an enhanced for loop because I need to sequence through. But the problem with an enhanced for loop is it does not give me the index value of where I am. It just sequences through the whole thing. Here I do need to use the index value, so I have to use a regular for loop. So check if the temporary bank account A is bank account balance is greater than the current largest. So that should be. We'll just get rid of that because I don't have room to erase. So what we're doing is we're checking this temporary one here. Is that balance greater than the one that I currently said was my biggest? And at the beginning, I start that to the front of the line. If I find a bigger one, or every time I find a bigger one, I reset. Then I have to give it back to you. So then I return the largest. So I check that way. All right, if you were to look at the bank in page 303, it does all of these. So public class bank, this constructs a collection of bank accounts in an array list. I have an add account, which just adds. I have get total balance, which sums up the total of all of my accounts with an enhanced for loop. I have count, which counts the number of bank accounts in an enhanced for loop whose balance matches a minimum with the parameter at least. I have the ability to find a specific bank account and return it using the parameter int account number. Otherwise I return null if I cannot find the given account number. And then I also have a get maximum. Now if I wanted to write get minimum, the only difference would be I would probably change my wording to smallest, and I would change right here, and instead of a greater than, I would have it if my current temporary bank account is less than my smallest one reset. So the tutorial is in your the folder for access. If you should run it and understand it so you can then copy those methods over for any of the homework assignments that you may need them to use. So self-check number 9 on page 306. What does the find method do if there are two bank accounts with a matching account number? Alright, so in this case, if I were to go back to my find an account number, I have this return statement right here. Alright, now as soon as that my account number equals the one I'm looking for, this calls the return and it kicks out of the loop, and in fact it kicks out of the entire method. So if I had two bank accounts with the same account number, it's going to return the first one it finds. It'll never make it to the second one. Self-check question number 10. Would it be possible to use a for each loop in the get maximum method? That is to say, an enhanced for loop in the get maximum method. And the answer is yes. The problem is that your first comparison would end up failing when you were to run it. Alright, 7.6, moving on. Alright, this is two-dimensional. Arrays. Alright, very important concept. In fact, the entire grid in Grid World is a two-dimensional array. So two-dimensional arrays, from a tabular two-dimensional arrangement, you access elements with an index pair, so A of some row value, and then in brackets some column value as well. Okay. So instead of just one index, now I have two. So you can think of, all right, columns go up and down, rows go across. So this spot right here would be a spot row 0, column number 2, because they do start upper corner at 0 and 0. Okay, this one is A of 2, 0, row 2, column 0. And otherwise, you initialize them in a very similar manner. Okay, you're going to make a new, new board. If we're going to go through, for instance, the tic-tac-toe example, makes a string, two-dimensional array of strings, and you just initialize it like normal, except you now have to set two numbers instead of one. And you will traditionally traverse filling or searching a two-dimensional array. You will traditionally traverse them as a nested for loop that generally looks like so. So this is the for loop that will fill our string, our tic-tac-toe board, with empty strings, so there's nothing actually there. So generally it's going to be int I equals 0, I is less than, depending on how you want it, usually some constant rows, which we would have used earlier to initialize, I++, for int j equals 0, j is less than my columns, j++. In this case, I have a two-dimensional array called board. Board I of j equals an empty string. So that's your traditional format for the setup for a two-dimensional array and the nested loop to traverse through one. Alright, so go ahead and look at page 307 at tic-tac-toe. It's in 2dim as the tutorial goes for two-dimensional. And if you notice, so we set up our instance fields. Remember, this is the older book. It does it at the end. But I have private string, two-dimensional array string board, private static final int rows and columns. And then I have a constructor, public tic-tac-toe. Actually initializes my board to a new string of rows and columns. And then I fill it, I'm sorry, not with empty ones, I fill it with spaces. Alright, so a nested for loop to go through and fill each section of my board with a space. Then I have this method called set. So it gives me a row and a column coordinate, and then the player, as in this case the player being an X or an O, so what it's going to put onto it, and it's going to put that string into the board. Okay. Then toString actually prints out a rough approximation of what the board looks like. So straight line bounding boxes go through each row, print each column in the row, then a new line, and then return it. Then the runner, that's actually the trickier part. So we have a scanner, which is going to take in user information. All right, the player is an X, computer is going to be an O. And while you're not done, as the board isn't filled or somebody hasn't won, you're going to print the board, print a row to enter, save it, then print a column and save it, then flip-flop the player. So in this case I'm actually only going to enter rows and columns, and it will automatically sequence between one player and two player. And then you keep going until you end. Notice this one is very simple. It doesn't actually keep track. It only checks if you've pressed -1 to quit, so you have to make it a little smarter to determine if you've won. Alright. Section 7.7 is very important in that it is another section of specific array commands. Alright, specifically dealing with copying arrays, okay? Not an array list, but an array stores variables as a reference to the array. Copying the variable would just give me a second one. So, we've done this before, But this is an object reference, which is just the memory address of where to go find the actual array. So if I made two arrays, one called data and then one called prices, and I set prices to equal data, I now have two names for the same array. Now I'd have to make an entirely new array. Notice one way to tell if what you've done is I only made one new one. I haven't made the word new twice, so there's only been one new array created. Now if I wanted to take an array and I want to make a second one, I'm going to use the clone method. So instead of my second line here, which is a mistake, let's go fix it here. So a double array called prices equals, and we have to cast it to be a double array type. That's the one trick. Okay. And we call data and dot clone. The clone method will actually take care of copying everything into a new array. The one trick again is you have to remember you have to cast because it comes back as type what's called object to make the clone method a little simpler. Okay. If I need to copy elements from one array into another array in the middle instead of copying the whole thing, then you can use the static system array copy method, which is shown on page 312, where you give it a from, which is a starting array, a index to start at, the to array, the index to start copying, and then the count, that is how much data you need to copy. Okay. Another use for system array copy is shown on page 313, is to grow an array that has run out of space. So you're going to make a new array, insert the old data, and go from there. Right. So if you look on page 314, that's what we're going to do. So you're going to create a new, larger array. In this case, we're going to double my data, called new data, copy all the elements into the new array with a system array copy, starting at index 0 of data and index 0 of new data, and copying everything, that is all the way through index data.length. But notice it's going to stop one before then, so you end up, you got to be careful. Store the reference data to the new array in the array variable, so data equals new data. So just reset. So if you look on page 314, it shows you those steps. Step 1, create an array called new data, which is twice the size. Copy all of my elements in, and then reset my pointer. Instead of pointing to data pointing to the first one, data now points to the second one. Alright, you should understand and read regression testing. We're not going to really do much about it because we don't use command line compilers, but it would be something to play with, and we might do something with it in class just for fun. But read over it, and then you should read on page 322 the Therac 25 incidents, just to keep in the back of your head how careful you do need to be. Sometimes there's a lot riding on your program, how easy your program is to understand, how well it works, how sort of durable and robust it is, how easy it is to break it, and more importantly, if it breaks, how easy is it for somebody else to come in and fix it, years and years later possibly. So remember, use these common arrays, algorithms, don't try to rewrite them, understand them, get good at using them, particularly a nested for loop for traversing through two-dimensional arrays.